Hello again, everyone, and welcome to the Design World webinar series. Thank you all for attending today's webinar, Extending the Automation Toolbox, Introduction to TwinCAT 3 Software and Extended Automation, which is brought to you by Design Magazine and Beckoff Automation. We would like to thank our presenter today, Robert Trask, a TwinCAT specialist at Beckoff Automation, for being here. I'm Leslie Langnaw, Managing Editor at Design World Magazine, and I will be your moderator today. Just a couple of housekeeping details before we get started. The webinar will be available afterwards for everyone who registered for it. It will be on our website, designworldonline.com, and you will receive an email link to that website. We will have a question and answer session at the end of the presentation, but there is a box on your webinar screen where you can go ahead and enter questions in at any time, and once Robert is finished with his presentation, we will begin asking those questions. If you wish to tweet about this or discuss this online or after, you can use the hashtag DWWebinar. And so now I'm going to introduce you to Robert. Robert Trask is a graduate of North Carolina State University with a degree in electrical engineering, and he's a professional engineer with more than 23 years experience in automation software, programming, and motion control and engineering for industrial applications. At Beckoff, he focuses on systems planning and management for open control systems and manages Beckoff's West Coast Technical Center in San Diego. And as I mentioned earlier, he will be available to answer your questions after the presentation. So without further ado, I'm going to hand over the mic to Robert.
Okay, thank you, Leslie. I appreciate everyone's attention to this. There are some very exciting things going on in automation, and we're going to talk some more about that. We're really in the middle of a revolution, and part of that, enabling that revolution, is our control package, which is TwinCAT 3. And it truly is extending the automation toolbox, because the programming of control systems has historically been more of an island, the island on itself. Now it's being branched out into all aspects of the enterprise and the company and the networking and the connectivity and the devices and the sensors. And this presentation is going to go into some of the things we're looking forward to with all that. I want to say right out of the box, we are very much, and we being Beckoff, we are very much a PC controls company. So everything we're talking about, we use Intel and we use Windows. Those have worked very, very well for us over the years, and we, with the continuation of the technology, with the advancements, we see no end in sight. Okay, we're going to do a little introduction, and we're going to talk about the concept of extended automation, talk about connectivity, a migration from older control systems to new control systems, functions, what sort of things can you do besides just the control, and then a quick product overview. So we've been doing this a long time. We've had TwinCAT 2 since the mid-90s. And again, all PC-based. And some of the things that have worked well have been the scalability to have it work on small systems as well as larger control systems. We've always preached and lived openness. And we have an amazing repertoire of field buses we work with. We have a protocol we openly share with C programs, anything .NET, with National Instruments, any of the major players out there with software. All the major field buses, the devices, the Circuses, increasingly these days EtherCAT. And again, always with Microsoft operating systems, we know how to control Windows. It's something we know how to have done for a long time. We get all the goodies with Windows, but we can still have a highly deterministic control system go along with it. And we can do this from simple marshalling of I/O to full CNC systems. And we do motion control and other things completely in software. We don't require extra hardware for doing motion control. So what customers have liked, they like the scalable aspects of it. They like the fact that it was feasible for small systems as well as larger systems. They like the openness of the field bus. The networking, the sharing of data has been a big hit over the years. The ease of doing this doesn't require anything purchased component. And the tools very often are free. And we have the ability to run any third-party Windows application without affecting the control system. At the same time, over the years, customers came to us and said, you know, here's some things we'd really like. We would like to have one tool for one project, just one development environment. We really, there are times when we have a highly mathematical-oriented system. We really like to run C code and do it in your real-time thread. Matlab Simulink for simulating systems. We would like to be able to maybe plop that into your control system to either run a PID loop or maybe simulate a process. We really need to use the cores. We really would like to use the 64 bits, the newer systems. We want things to be more modularized, and we'll talk about that later, the objectness of things. We want to be able to migrate from 2 to 3, and they really are two vastly different things, as we'll see here shortly. You have a great visualization. Keep it. You have an internal protocol for communicating called ADS. Works, don't change a thing. And more importantly is version control. As systems grow in complexity, you have more programmers, you have more people involved. Version control really becomes very, very difficult. And now, when things are more modularized, we want to be able to control individual components, to check out a component to a program or bring that component in, to find out what changed, when it changed, how it changed. And we like to, keep up with the modern look and feel of computer software to the editors. So that was the wish list. So the motivation for us was to have one software on one CPU. We call it the power of one. Do everything on one CPU. It completely minimizes hardware, less control systems, less expense, less complexity, less cables, less footprint in the panel. And we really have been doing this for a long time. Have the motion, have the HMI, have the control software, and any other thing. Do it on one CPU. And the whole PC control concept really supports the whole openness, the open control system. Abstraction. We have a slide later on describing abstraction. What that means is I want to separate myself from the details. I take care of something in one place. In another place, I don't have to worry about the details. The analogy I often use is driving a car. I'm able to drive my car. I know very little, really nothing of what's going on inside, but I'm able to sit down, turn the key. Those are my interfaces to the car, and yet manage this complex piece of machinery without knowing all the inner details. PC control, object-oriented, these different concepts are really supporting this abstraction, this separation of concerns. And when we feel very strongly that whenever you can do something in software, rather than hardware, you're better off. And as our world is merging with IT, the automation world is converging with the information technology world, we can both share these benefits. Beckhoff, again, has been in the game for a long time, and now with the release of TwinCAT 3, it ties us in even further with the concept of, you're hearing the term Industry 4.0, and also the Internet of Things. It's generally considered that there's a fourth revolution. We're at the beginning of a fourth revolution, the first one being mechanical, the first industrial revolution using mechanics, than at the beginning of the century using electricity. About 30 years ago, the solid-state use of control systems, doing control systems using solid-state devices rather than mechanical relays. What's going on now with the connection, with the internet, with the web, with these different technologies, with the extreme power of PCs, is we're shifting to a whole new world. And we're trying to prepare ourselves and prepare our customers to both embrace and help shape it. Okay, extended automation. This truly is an extension. We're taking, like I said before, we're taking what we had existed with TwinCAT 2 and we're extending it out. We're opening it up for any of the technologies that are out there, totally future-proofing it. We'll show you how here. Visual Studio. So Visual Studio is our IDE, is our integrated development environment. It is by far the world's most used programming and development environment. And we've hitched our wagon to Intel. Now we've hitched our wagon to this other very large, very well-researched, great compilers called Visual Studio. And what that does is open up the other languages. So I can do the real-time, I can do the TwinCAT, I can do the highly deterministic synchronous stuff, and I can also run a C# program. I can run an Iron Python program. It opens me up to anything that's a Visual Studio plugin. So again, it's an extension. It's a tool. It's a tool. And as we talk about these components, we really are. This is a large toolbox. And I was talking with a colleague earlier, and that's a great concept, a toolbox. You have this toolbox with lots of tools in it. You don't use them all every time, but when you need them, sure is nice to have them there. Again, one programming environment, one project file, one debugging environment. And all this is wrapped around the IEC 61131-3 third edition. The third edition just got finished after 5 years of some rather significant changes. And the third edition was released earlier this year, where TwinCAT 3 is totally on board with all of the changes to 1131. We now, as we said, have the ability to cyclically execute C, C++ code and have synchronized deterministic access to the I/O system. And that's a very powerful thing. Probably half the people now who are using TwinCAT 3 are using it primarily for the C and C++ benefits. So one of the first questions we often get is, I'm not a Visual Studio user. I don't have a Visual Studio license. Do I have to buy a license? No. You do not have to buy a license. When you install TwinCAT 3, if you don't already have a Visual Studio development environment, it will install a royalty-free shell. It's another thing Microsoft does to enable others like ourselves to use their environment. So we still get all the automation. We get the PLC, we get the safety, we get the motion. We can run C code, we can't develop it. And we can even run Matlab Simulink code. And all this is without cost. Now, if you do have a Visual Studio, if you are a Visual Studio user, great. Now, TwinCAT basically is a type of project that you open up, and you can have everything else there at the same time. And again, one debug environment, which if anybody's done much programming, is a very handy thing when you're working on an HMI and also working on a control program. And sometimes it's a chicken and egg thing. What's causing a problem? To have one debug environment greatly simplifies the creation of code. So, TwinCAT 3 is Visual Studio, but the framework works in Visual Studio, period. That is a development environment. So, again, it's by far the largest. For us, it was I've often get asked, why would you ever use Visual Studio? And our answer is, why wouldn't you? It's incredible. The powers are there. You have all these plugins. It's managed by a very large, very successful company. It's not going to go anywhere. It's not going to disappear in 2 years. And it helps us with our help system. It helps us with the help files. Again, we have all the .NET world opened up to us. Now, when we're in the environment, what's great is we have a free choice of languages. We have the PLC, the classic programmable logical controller languages, as shown on the screen on the right, even graphical, even ladder. And on the left, we can use the more complicated syntactual C languages. Most projects that I'm involved with have a range of programming experiences. Sometimes people are really, they're computer science, they know this stuff. Other people are more graphical, want to drag and drop. We really have an environment now that has both. So again, a toolbox, so you can pull out the tools you need when you need them. Very much a tree structure on the left. So the organization is very similar to what we're used to, a folder type structure. On the right is a toolbox. So for the people who are graphically minded, a graphical language, and that's one of our messages is we're not trying to make things harder for anybody. We're trying really to make things simpler, even for the non-computer scientist. So we do have an environment, even though it's Visual Studio, when you look at it, it looks quite a lot like any other programming software, ladder type software that we're used to. So we really truly are able to support a simple automation machine that's lifting a box up and down to a full-blown multi-processor, multi-axis system. So the concept of abstraction, we talked about it a little bit. This slide brings it home for me. At the bottom level are things I can drop on my toe, a drive, an I/O sensor, things I can drop. I put those together. I often have to do some configuration of them, and then I can now communicate, and that's the second level, the orange level. I now have a field bus that communicates that information from the device to a controller. In our case, for the motion controller, now we have a motion controller that now says, okay, here are your scalings. I'm getting back 2,000 pulses per revolution. Takes care of all those details for you. By the time you get to programming, you are completely abstracted from having to worry about anything. I say move 10 things, and based on how I've gotten the scale, based on how I've set the system up, it's going to move 10 inches or 10 meters or 10 degrees. But I'm abstracted from having to worry about it. And our whole system has always been built on this, but now we're starting to build control systems completely using this, using lots of objects to try to abstract ourselves from the complexity of the system. And for motion, we can do the whole gamut from simple point-to-point to interpreted language where I can give a radius and a point and say move in the circle, and it does all the math for you, to full-blown CNC. Increasingly, we're seeing what we're called kinematics, different libraries like Scare and Delta, these different libraries of functionality for motion, again, taking care, abstracting you, doing the heavy math, doing the heavy hitting, and they're actually quite simple to use. So robotics, the kinematics is the most interesting thing we're working on, the newest part of all this. C has been a big hit. We were actually kind of surprised about that, but it has worked amazingly well. I've seen it. We have some biotechnology companies in California, and some of the math they're doing with the C code, and to have a cyclic execution of that code, and also we have the live watch window, which even Microsoft has wondered how we got that done. So if you ever really need a heavy hitter, a heavy math hitter, we could talk about using TwinCAT, the C part of TwinCAT. This is just showing the cyclic area for it. So when you invoke the C option, what it does is create the background code for you. I had an interesting observation from a friend, Bertrand Meyer, who actually is one of the forerunners of object-oriented programming. He lives in Santa Barbara. And went to lunch with him one time and was showing him this. And he was impressed. And his comment was, the code that you never have to write will never break. And all this code, the background code, you just start putting in things in the cyclic areas. All the other stuff is done for you. Again, it's a tool. It's part of extending the tool. Bringing difficult things to you in the simplest way possible. And Matlab, this is anybody who's used Matlab, it's quite a piece of software itself. It's an amazing thing, and we're more skilled at using it within TwinCAT than actually doing the Matlab. But at the same time, we're seeing people create, most recently, create their own PID. And they created that. They had some special gains and some special inversions of the code internally, and they wanted to run that in TwinCAT. And so there is a mechanism in Simulink to say, go ahead and create a TwinCAT module, or excuse me, a Visual Studio module. We bring into Visual Studio, run it in our kernel. Better than that, as you see on the screen, we can actually poke in and look at the values online and even write the values. And that's never been possible. And that's been a big hit because, again, debugging and manipulating and simulating becomes simple. It's amazing. I'm just showing you, here's another screenshot of Matlab inside TwinCAT. So the big thing for me has been the online monitoring of parameters, so I can look at all the parameters in a block. There is a provision to use breakpoints, which is interesting to go up to a process and stop. We mostly use it for assertions, waiting for certain conditions, and when we get to that condition, it'll stop based on, okay, go or no go, basically. But again, we can manage all this within the TwinCAT without having the separate Matlab running. So we create the module in Matlab and pipe it in here, and we're still able to do these things to manipulate change to the Matlab code. The big thing is now that all the .NET languages are open up to us. Of course, C# is probably the most widely used. I've become recently a fan of Python, Iron Python. But we have VB users, we have other odd language users. If it fits in Visual Studio, we're all about it. And we give you the tools to communicate to them. It's all internal. And at the ADS layer, we have these tools to easily communicate information between these different languages. So again, efficient engineering, higher abstraction level. So I can do, if I have some algorithms I've written them in C#. I keep them there. I communicate to the control system through the ADS mechanism. And once again, there's that abstraction working for us. And these things are widely accepted. Anybody that's graduating college now has had a pretty good run at any .NET Visual Studio environment. It's often asked, can I do control with C#? And the answer is no. Fortunately, because C# has an automatic garbage collector, and it's the same for Visual Basic too. We have to consider those what we call user mode, the non-deterministic area. At the same time, we have our deterministic, our highly cyclic environment, and our user mode stuff. We're all in one programming environment. So this is an example of looking at the tree of multiple things going on. I have a C# app. I have my PLC logic. I have my real-time C code. and I have my real-time I/O system. And again, I manage it all from that one tree. So again, trying to keep complex things as manageable as possible to us. That is our goal. The runtime has now been split up into different modules. So rather than being one giant program that runs, and again, this ties into source control too, both source control on the runtime and also on the development end. So when I have individual modules, I can change one without worrying about changing the other. And this was a concerted effort on our part for the past few years to become more modular rather than having one big thing. So on the runtime end, which can run very lean, when we have this application, when we're developing these things, they often take up a lot more room than the actual machine code. Consequently, we can often run quite complex things on really inexpensive processors. We don't have to have the 8-core, Intel 7 like my laptop does to run code. I can often run it on something much smaller, hence less expensive. So it was, again, a very conscious effort on our part to have both leanness and modularity in the runtime. This is a popular item. Now with multiple cores, what's interesting is for years we've been doing motion, we've been doing the PLC, we've been doing the HMI, we've been doing them on one core. With the recent advances in multiple cores, we've kind of gone back to, this is interesting. And now it's possible to split up. Maybe I can run 80 axes on one core, just devote that all to motion control. Now maybe I put my HMI on one core, and maybe I do all my PLC on another. So it just multiplied what can be done, what the control system can do. And with that in mind, we're thinking, okay, I got all this nailed. What else can I do? And things like condition monitoring are becoming real. And what condition monitoring is, okay, I have vibration sensors on a bearing. I take that as input, I sample them at a very high rate, I run them through a Fourier transform, and I look at the frequencies. And I look at this over time, and I can look for maybe a particular frequency crops up that wasn't there before, and it's an early indication of a mechanical wear, a mechanical breakdown. So we're really thinking about what can we do with these other cores? What can be done? And condition monitoring, vision systems, again, more kinematics, more robotics are the things we're really thinking about doing with multiple core processors. And it's wide open. It's just absolutely wide open right now. Just a little graph of kind of further talking about the multi-core. So we're there. TwinCAT 3 is able to do it, does it very well. It's a very easy interface. There's no complicated settings. There's no registry, no anything. It's all managed in a very easy place. And it's remarkable how much effect you can make from a few changes. But having the split up, and the big thing also is to provide the communication between cores, because the cores really are individual CPUs. So you can have things executing on different cores. You still have to consider how they talk to each other. So we provide the interfaces to talk between those cores. And here's the interface I was talking about. And again, it's click, change, everything's enumerated, so I know. And I click on CP0 or CP1. I don't have to. There's no computer science-y mumbo jumbo behind it, and it really is remarkable, and it's all there. Okay, connectivity, always an issue. If we build a complex process, we're talking about Automation 4.0, great, but I have to provide the connectivity. And like I said, it's always been a focus of ours, but now that we're in the Visual Studio environment, and now that we're in one environment, totally opens the doors for the SCADAs, for commuting things over radio frequencies, for remote access, for talking to databases, for ERP systems. One thing we're highly interested in is scientific automation, kind of alluding to that condition monitoring. Matter of fact, if you go to www.scientificautomation.com, it takes you to a piece of the Beckhoff site. Again, thinking about what can we do with these cores, what are the things going to be done in the future. ADS is a protocol we use. It's an open protocol. We have to use it to communicate to our real-time system to do the buffering between the real-time system and the non-real-time, the windows, the user areas. Consequently, we use the same tools to communicate to everything. And this was the big hit of TwinCAT 2. We haven't changed it in a long time, and it didn't change for TwinCAT 3. It's a very, very solid protocol that we've been in development for a long time and just works like crazy. And the components are free. So the ActiveX control, a .NET component, DLL if you're using C, these are royalty-free components. It doesn't cost people to develop anything to talk to these devices. So, keeping in with Industry 4.0 and the Internet of Things, we're a PC, we're still doing control. We want, what about all the other tools? And this is a great slide to show, wow, OPC, the industry protocols, the power, the wind farms, they all have their different protocols. The IT protocols, the wide area networks, the Bluetooth, of course TCP, the email servers, and AJAX, the web developments. We now have all these tools at our disposal. So here's our toolbox analogy again. So extending the Automation Toolbox. And it was, again, a very conscious effort on our part to future-proof ourselves because we don't know what's going to be the hot thing in 2 years. We don't know what's going to be the hot thing really next year. So how can we allow ourselves to move forward and allow these things into the mix? And TwinCAT 3 is that tool. So migration is a popular subject. We've been doing this a long time. There are many, many hundreds of thousands of installations running processes of machines with TwinCAT 2. It was a focus from the start. Whatever TwinCAT 3 was, it had to be able to migrate. You had to be able to migrate TwinCAT 2 into it. It is a one-way street, but I can say after a year, we've had a remarkable, successful time of bringing TwinCAT 2 projects. I mean, fully formed, motion control with HMIs and everything. We've had great success in bringing those into TwinCAT 3. And it's astounding. So if you are a TwinCAT 2 user and thinking about this, the migration is a complete success. Functions, what we called before supplemental libraries, we're now calling functions. And things like, okay, I need to talk Modbus TCP to a device. Well, it's a function. It's a library. By the way, TwinCAT 3 contains all these functions already. You just add them as you need them. The communications are a big one always because every control system every control system of any size has to communicate to other devices. So the Modbuses and the serial and Ethernet TCP are always used. We have a temperature controller, auto-tuned, ramped with very advanced temperature controller. With that, we have a toolbox with hysteresis and different signal generators and different filters. Engineering tools. Source code management is one of my big things, so I'm a nut for two things. One is managing having an easy check-in and check-out method for modules for project modules, and also intellectual property protection. So the tools that are out there, the two ones we're seeing the most right now are Team Foundation Server and Subversion. Both have the mechanics to password protect things and to individually check things in and out. And one of them is free. Subversion is free. So it should be a no-brainer for anybody doing code, is to really start to embrace, if you're not already, source control management. There's an inboard oscilloscope. It was called Scope 2 within the Visual Studio environment. It's called TwinCAT Measurement, but there's a tool in there for you to use, again, royalty-free. So, quick summary of the highlights. TwinCAT tool, TwinCAT 3 tools and highlights. One software for everything. One software for the programming, one software for the configuration, and again, the ability to plug in any other .NET or C or anything else that's out there in the Visual Studio. So it gives you complete freedom in the choice of your programming language, all the IEC plus everything else that's out there. The links to a simulation program, a very highly regarded and widely used simulation program called Matlab Simulink. Completely open interfaces to the field buses, to other communication programs, to internal between languages. A faster and more flexible runtime environment. So like we said, it's very modular and it's lean. And with the latest PCs, the support of multi-core and 64-bit system, and then the migration. Over the years, Beckhoff has joined concepts together to better the automation world. In our opinion, it's worked very well for us, and the trends are definitely there. The world seems to be headed this way. So in the mid-'80s, we took the Intel chips, the 8088s, the 386s, joined them with the off-the-shelf computers and PC-based control. Then we took our real-time system in the mid-'90s, combined it with the Windows and Windows embedded systems, and there's TwinCAT. We took the big, wide variety of field bus systems and are able to bring them together using the existing things and merge that, put all the things we learned, all the mistakes we made with Profibus, all the mistakes we made with DeviceNet, and now when Ethernet was clear that it was going to win, okay, how do we take all the things that we learned and make something that is bulletproof, and that really became EtherCAT. So learned a lot of lessons along the way. Now we have our automation software, the 1131 stuff we've been doing for a long time. Let's put it in Visual Studio. Big world opens up for us. So it's a convergence of technologies, and we have a history of doing this. And it's all supporting the concept of Industry 4.0, the fourth revolution, the fourth industrial revolution. Okay, that brings back us to the end of the presentation. So, Leslie.
All righty. Thank you very much, Robert. That was an interesting presentation. Just a reminder to everyone, if you have some questions that you would like to ask Robert, now is the time, so feel free to go ahead and enter your questions into that question box that's on the control panel. And we do have a couple that have come in. So the first one is there any integration with R or Octave? I'm not sure what
I am not familiar with either of those. So if they can plug into Visual Studio and they can accept the .NET component, the answer would be yes.
Okay. Are there any kind of applications where you would not use this software?
That's a good one, and no, because it doesn't. Again, it's a toolbox, so it doesn't. If I need only a screwdriver, I only go get the screwdriver. When I boil it down, what it might be running on something very small. We have ARM processors. We have very processors that basically have phones, chips that are in phones in them, and we can run a couple of axes of motion and do maybe even a pure ladder program. So I really can't think of a reason not to use it because it's so scalable, and I don't have to use all these components, and of course most of the time I'm not. I can still use the very simple basic components and not have it be that complicated.
Okay. Can you integrate with Scilab Xcode, which I guess is an open source alternative to Matlab and Simulink?
If it generates C code that doesn't make any DLL calls, or excuse me, API calls, and doesn't have any constructors, the answer would be yes. So the question is, when it compiles, is it compiled down to C or C++? And as long as it's not making basically something that's non-deterministic, because we run this in the real-time kernel, and we can't have any constructors there. So the answer is a definite maybe. And certainly we can investigate this, and you can get in touch with us, and we can look at it further with you.
Okay. Are there any other questions? Oh, here we go. Oh, here's an interesting one. When are you guys going to have training in certain areas of the country? How do people get training on this? I'll ask that question.
Yeah, we're working on it. I think we're starting very soon official TwinCAT 3 classes. We've been doing them for about a year for specific customers, very application oriented, and been in the process of coming up with a curriculum that's geared toward TwinCAT 3. We've also been investigating doing more YouTube type videos. But what's interesting is we have application engineers all over the country, and that's a large part of and my job is to sit down with people and work with them on that. What we find is people that have used any kind of automation software pick up on this stuff very, very quickly. So the training really doesn't take that much time, all things being equal. So the answer is check our website for training dates and get in touch with your salesman or local application engineer and see if you can wing some of their time.
There's a couple of questions here that are highly specific to the individual asking the question. I'm just going to let everybody know that these questions will be seen by Robert and other people at Beckhoff, but we're not going to ask them here on the webinar, but they will get them and they will answer those questions for you in the next day or two. Another question that has come in is about robot kinematics, and is it integrated into TwinCAT 3 or is it an add-on?
It's an add-on, and both. It's integrated, of course, but it's an add-on. What it is in general, they're a function block that you pipe data in and get pipe data out, and we have 29 different variants of it. So the answer is yes, it's a plug-in, and yes, it's integrated. And if you have a specific style of kinematic that you're interested in, just get in touch with us, and we'll start working with you on that.
Okay. That sounds good. Are there any more questions coming in? And if you don't want to ask your question on the webinar, please notice that on your screen you should see Robert's email address. So you could also email your questions to that. There's also the phone number. So either option is available to you. Now we'll hold on a minute here and see if anybody else wants to ask any more questions. And it looks like that might be about it. So thank you very much, Robert and Becca.
I didn't need to add one thing. I did see a question float by that I want to address. And
okay.
A lot of people say, "Oh, this is all great. How much does it cost?" And this is the most amazing thing is there is zero cost to get going in TwinCAT 3. You download it, And again, if you don't have a Visual Studio license, it'll put a shell in there. You can use all the libraries. There is no cost to get going. How do we make any money off it? Well, when you want to deploy it, when you want to create the runtime that doesn't, a permanent runtime, then we start talking about licensing costs. But to get going, there is no upfront cost. There is no development cost.
All righty. So just as a reminder, this webinar will be available at the Design World online website probably tomorrow. Everyone who has registered will receive an email link to the webinar. You can still continue to tweet with hashtag DWWebinar. You can also connect with Design World on all of our social sites, including Facebook and Twitter and Google Plus and LinkedIn, Pinterest and YouTube. And we also have an engineering exchange, which is just a social media site for engineers. And you are welcome to continue the discussion on engineeringexchange.com. So, Robert, thank you very much for a very informative seminar. Thank you.
Okay.
All righty.
Bye-bye.
Goodbye, everyone.